Okay. Good afternoon, Valencia. Welcome to my session. Thank you for having us. First time at KubeCon, first time at CNN DB Day. I'm an Oracle person. You've all been told that Oracle's 30 years old and it doesn't live in the Kubernetes world. So I'm going to talk about databases and how SQL databases are still relevant in containerization. So this is me, Ron Ekins, as introduced, Principal Architect in the Office of the CTO at Pure, Oracle Specialist, Subject Matter Expert, been working with data as a data professional for 30 plus years, from a development, sysadmin, database administrator, enterprise architect role. So I've been using data for a long time. I've got 5 patents around data protection and security. The challenges we have in Kubernetes and that panel session there, some of those problems we've had for 30 years and we've fixed those. So we can actually learn from the experience we've had in traditional databases and apply those to containerization. Oracle ACE Director, so that's a community award. It's not an Oracle job. It just means that like Microsoft MVPs, VMware is vExperts, Oracle's Oracle ACE program, and I'm an ACE Director, so I'm very proud of that. So today's session, containerized applications and databases, why Kubernetes Operators, and database Kubernetes Operators. We'll drill into those. I've got a very small session today, so I'm going to be quite fast. I normally speak Oracle conferences, so I normally go a lot deeper about the Oracle technology, and I'm actually presenting in Kscope in the US next month. So if you go to that event, you can see a deep dive. It's going to be about an hour-long session. But just to introduce databases and operators. Okay, containers and databases. So I don't have to tell you what an operator is. You're all the Kubernetes experts. But what do? If we think about it, it's exactly the sort of demands we want for our databases. We want to know where we put them. We want to manage states. We want to be able to start things up. We want to be able to shut them down. We want to keep things up. Load balancing across servers, networking, persistent storage, declarative mode. These are all the tenets of a database. The persistent storage has made databases a reality on containers. And that's what we're going to talk about here. I guess the one takeaway from the database world is, K8's main task is to make the desired state the actual state. When we define the database, we want it to run and we want to know how it's going to run. It's a challenge for the database world. We're used to having fixed names, fixed storage. We know where our database lives. We know where the storage is consumed from. Permanent IP addresses, permanent names. That all changes in the container world. So, you're going to have to help educate data professionals like myself what it means to run a database in a container. But why should we containerize databases? It's all of the reasons that you're running stateless applications in containers. It's allowing developers to concentrate on the code rather than the infrastructure. Deployment automation. We talk about automation a lot. It's the speed at which we can now deploy. I've been using Ansible now for about 5-6 years, and throughout my career, automation's been a big thing. But what's changed, I guess, in the last 5 years, it's full stack automation. So where we may have had a developer having some build scripts, and maybe a DBA having some backup scripts or some deployment scripts, or a network person having scripts to define firewalls. Now we all collaborate. We build storage, we build networks, we build applications, and we can deploy those via common playbooks. Reduce complexity and system resources. Databases are heavy things. They're not really your classic containers. Heavy I/O, lots of network usage, lots of memory. We have to think about the way we deploy applications to make sure that they work in a container world. But the benefits for the database is we can actually deploy more. We get lots of flexibility when we containerize a database. We reduce complexity, reduce the amount of patching, the deployment costs that we traditionally have with a database. It's an enabler to DevOps, CI/CD. We talked about deployments in the last session, about doing releases. People do releases a lot quicker. I've worked on projects where we were doing 18 months for an Oracle E-Business Suite deployment. Now we see deployments every month, every week. It's a lot quicker, smaller releases, but more frequently. enabler for database as a service. You know, the as a service model is going further and further up the stack. We've started with infrastructure and our platforms, and now we're looking at databases. You know, we see SaaS at the other end, and they're coming together. You know, everything as a service. Portability across environments. You know, there are many clouds, many different environments. You know, we want that portability. We want our application to be able to run anywhere. You know, anyone that works in an application world has to rethink the way they deploy. You know, we got to start thinking as data professionals and IT professionals, it's not about the server, it's about the service. And for me, it's always been about the database service and the data. Now, we're all speaking the same language. It runs everywhere, in the cloud and on-premise. Okay. Why Kubernetes operators? You know, what do they do? What do they give us? A way to package and manage Kubernetes applications. We can ship applications and we know what they look like. Easy to deploy, easy to build. We can move those across clouds. Addressing some of the challenges we talked about with databases being hardwired to server names, hardwired to storage. We remove that. Give these the flexibility to deploy anywhere. Consistent deployment is a big challenge. And that's one other thing that operators give us. The ability to deploy wherever, and we know we're going to get the same results. You need to test it. You know, in the last session, there are differences between some of the clouds. But if we can use an operator, it gives us the best chance of getting a consistent deployment. Test it, make it repeatable, whether that be in the cloud or on premises. This is a screen grab from operator.io. So this is a marketplace for operators. You know, this is just the database category. 38 databases there. And this isn't all of them. This is just people that put their operator into operator.io. And we can see EDB. We can see Pacona with their MySQL and Postgres ones. And we've got Postgres there, we've got Postgres there. MongoDB, MariaDB, another Postgres one. There are multiple Postgres operators, multiple MySQL operators, and they're all slightly different, all giving us different services, different features. Makes it quite complex if you have to choose which one to use. So looking at Postgres, the CrunchyDB is a really popular operator. And I think if you go to KubeCon main conference, you'll see that they're there. You'll also see Pacona there, and Enterprise DB. If we look, they all have their own main feature lists. This addresses high availability, it addresses disaster recovery, it addresses advanced configurations. When you choose your operator, you need to make it on a basis of what do you need out of that operator. So you go back to the business, you ask the developer, ask the application owner, what is the application going to look like? Is it a single node application? Is it a multi-node application? Is it over different geographies like the Cassandra application we saw first thing this morning? We have to actually understand what is the right operator. So you do that by identifying the features and drilling into those, which operator gives you those. And also look at support and maintenance. But it's complex. There's lots of small words there about security, certification. Do you need your database backups encrypted? Do you need secure connections? All of these need to be considered. We've been doing this in the database world for a long time. Now we've got to start distilling that into the Kubernetes world. So, if you're looking for a database as a service, what should you be looking for? Now, look at the life cycle. Look at the operator. Does it let you provision and delete databases and applications? Probably yes. That's probably the minimal requirement. It can provision something new and it can retire it. And when it retires it, you want it to tidy up. You want it to retire all the services. You want it to remove the namespace, the PVCs. It's got to clean itself up. You don't want to be paying for those resources in the cloud after you've retired that database. So let's have that as the number one requirement. Start and stop services. If you're paying for compute, you want the ability to stop the database if you're not using it. And start it up. Maybe it's a test database. You only have it running during the business hours. So you don't want it running over the weekend. So stop-start services. Advanced topologies. High availability, disaster recovery. Not all the operators do that. So understand your requirements, understand whether the operator gives you that. customized configurations. Do you want a Swiss Army knife, or do you want a tool to do the job you want to do? If you need a bespoke database, you need to go to the application owner, the database owner, and say, what do you configure today? Does your operator allow you to do the same configuration, the same customization, database parameters? Can you define how often the snapshots are taken or where the backup files go? Do you need to care? Not always, but sometimes you do, depending on the database. Scale up, scale down. It's not just NoSQL databases at scale. Something like a database from Oracle can be sharded, and you can have that scalable. You can have a cluster database. So we need to consider the same idea about scaling up within the data center, within our Kubernetes cluster. Rolling upgrades and patching. Now this is really important. We talked about Log4j. If you've got a large cluster, and you've got business users on that database, you don't want to have to take it away to do an upgrade. You don't want to have to really schedule that out of hours or negotiate an outage. It's becoming harder and harder to get a business outage with applications having been global, 24 demand, customer facing. You might not get that maintenance window. So you need the ability to do rolling upgrades where you can put a new image in place, take one node out, upgrades it, and the database stays up. Your application stays up. So rolling upgrades, rolling patching, looking for that. Database cloning. Database cloning is a really good way of testing your backups and your restores. If you can't restore your database, if you can't rely on the snapshots, then you've got a world of pain. So you clone the database, test it, give it to developers, make sure it's okay. When you start cloning, can you actually obfuscate the database? Can you actually change the database? You don't want to deliver a production database in the cloud to a developer that doesn't need to see production data. So you should have the ability to run scripts on that database before you release it. So this could be emptying workflow tables. It could be removing sensitive data. It could be actually adding manufactured data, synthetic data, which extends the data set for developing and testing. So your development database is the best place to start, but sometimes you need to take some of that out, change it, and maybe complement with new test data. So can you do that during your cloning? Database security. Encryption. You may have storage at rest encryption. But if someone's on that server and they could do a strings attach, can they just shell into your pod and see the data files? Well, that's a scary thought, isn't it? Can you shell into the pod and then connect to the database and see all the data? So the practices that we've had in securing our database and our data sets need to be also included in our ways of working for Kubernetes. So look at your encryption. Is your database encrypted? Is that a database option? Or are you going to rely on the storage platform? What about secured connections from your client? If you're able to query from a desktop to your database, whether that's sitting on on-premise container or in the cloud, is that encrypted, that link? Or can someone just sniff that and see your credentials, your data going past? What about your backups? Are you encrypting your backups? Are you putting them into a clear text format in an S3 bucket? Have you secured that bucket? There's multiple vulnerabilities there. So make sure that you are encrypting your backups. Make sure that your backups are going to a location that isn't public. Know where your data is and know who has access to it. The way we handle our data today is equally relevant in the new world with containers as it is today with traditional databases. Backup and restore. You may be using storage snapshots. You may be using file system snapshots. But can you guarantee you can recover from those? If you're using database vendor backup tools, most of those will test the integrity of the database. If you have just snapshots, maybe there's a database corruption. Maybe you've had a bad HBA and it's done a corrupt block. And you won't know about that block until you actually touch that block or you read it. If you've just got a snapshot, you've got that block there below the surface ready to bite you one day. So it's another reason why to test your backups, to make sure that your backup integrity is good, that you can actually use them. Use backup vendor tools to test the database and the database backups to make sure that the integrity, there's no block corruptions there. Use native backups, complement those with file system storage snapshot backups. Application APIs. Do you have API interfaces? It's great having a point and click, But if you want to go at scale, you need to automate that. So whether that's through things like Ansible, it has modules for Kubernetes, or Terraform, or other tools, you need to be able to call your databases, you build your applications, and automate that. Monitoring login metrics, the observability, being able to actually see what's going on, and actually exposing that. If your database as a service doesn't let you see the audit logs, can you satisfy that audit log requirement from your internal or external audit teams? If they want to say, who was accessing our application at 3 o'clock in the morning? Do you know? Can you see the log files? Can you actually demonstrate that you're in control? Think about that. Think about errors that go in the log file. Is your monitoring tool just for talking about CPU use and memory usage, or is it actually saying what's going on at the database application level? Who accessed what data when? We're getting regular errors in our backup scripts. Who owns those now? Is it the Kubernetes administrator? Is it the database administrator? Is it the storage administrator? Make sure you know who's looking at the log files and who owns them. Implement a semi-tool like Splunk where you can actually take all this information and have it analysed automatically for you. But think about where your data is, who's accessing it, and how you're going to be able to report and show that you're in control. Notification services. You don't want to have all this done manually. You don't want John having to come in at 8 o'clock in the morning and the first thing he does, he spends 2 hours looking at all the log files. Have those automatically scanned, security logs, access logs, and notifications going out if there's anomalies. Whether that be physical, virtual, containerized, or on-premise in the cloud, the same disciplines should be there. We should be looking at managing our data consistently. We shouldn't have one team which works in one way for containerized databases and another one for our traditional physical databases. The data is what people are after. We talk about ransomware and mitigating that, protect your data. So I've been using Operators for a while now, and I've done several blogs. I talked about using the EDB Postgres. I really like this one, a good operator, so have a play with that one. I've documented how to install it. That's very much a walkthrough, so you can have a look at that one. I've done one on Yugabyte DB, and that's interesting as well, because that's a distributed database. So that gives us even more challenges. If you have your data spread over different places and it's designed to actually be fault tolerant, where you can lose a geography and the data is split around. It's built, the data protection is built into the database. So look at that one. And also, Oracle is the #1 commercial database, but MySQL is Oracle's #1 open source database. So I've got something on there. And when people talk about databases and Oracle, Oracle's now coming to the party. So the Oracle database for Kubernetes Operator is available. It's in early release. I don't work for Oracle, but I am using this as part of the beta program. And what we're doing here is we have kube control, being able to manage databases, whether they be containerized or traditional databases. So this is really powerful now. We can have one language, we can manage all of our databases. And I think this is the way we're going to be going, because we're not going to be putting all our databases in containers anytime soon. It took 10 years for DBAs, Oracle DBAs, to move their databases into VMware. They may move quicker with containerization, but it's not happening next year. I'm seeing a few people do it, but not many. The way you install the operator is the same as any other operator. Pull the image and apply it. Take your YAML file, configure that, localize it, put the database name, the namespace, the database name, the PDB, the CDB names, where you're going to be pulling the information from, the images, the secret, all of the information that you would normally have in a YAML file, put that in there for the database, and then apply. And there we are, apply it, and that will build as a database. And then from a DBA, from an Oracle DBA's point of view, to Oracle developer's point of view, it looks and feels the same way as a normal Oracle database. And that's it. Got a database up. I have got a demo. I'm not going to do a demo now, but I am going to be around for questions. We were tight for time, and that's me done.
All right.
I don't think I'm going to have any time for questions. But if there is any, please grab me over a coffee.
I'd suggest we take that offline because we're on a tight schedule right here, and we would like to have